Today, we have prepared another 3 topics from the field of space exploration for you. We'll start with news about the landing of the Japanese Slim lander on the Moon. The second topic will cover the destructive test of the inflatable module from Sierra Space. The third topic will show why the Orion return capsule from Artemis 1 mission has been relocated and what its next task will be. We covered the landing of the Japanese Slim lander in one of the previous episodes of our show. To briefly recap, the landing occurred on January 19th at 1520 Universal Time. The Japanese lander communicated after landing, but at 1757, it had to be shut down because the photovoltaic panels were not generating power. Ground teams managed to download all data about the descent, including photographs, before the shutdown. Analysis of the collected data revealed, for instance, that at an altitude of around 50 meters, the lander executed an obstacle avoidance maneuver on the surface. Before this maneuver, it was targeting the desired coordinates with an accuracy of less than 10 meters, more precisely 3 to 4 meters. Just before initiating the avoidance maneuver, one of the 2 main engines suddenly failed. 2 seconds later, the navigation camera captured an image showing debris from the engine, including part of the nozzle. The onboard system recognized the anomaly and continued the descent with only one engine, gradually veering to the east. Contact with the surface occurred at a speed of 1.4 meters per second, which was below the set limit. However, due to lateral velocity and orientation in space exceeding the limits, the lander ended up in an unplanned position. Instead of the intended landing site, it was located 55 meters away from the desired coordinates. Nevertheless, the main mission objective, to land within a radius of 100 meters from the center, was achieved. Before landing, the Slim lander deployed 2 mobile devices on the surface, LEV-1 and LEV-2. The photo of the Slim lander was taken by LEV-2, also known as SORA-Q. This device, weighing 1/4 kilogram and the size of a small orange, showed us that the Slim lander is rotated 90 degrees from the normal and its photovoltaic panels are facing west. LEV-2 sent this photo to its colleague, the rover LEV-1, which can communicate directly with Earth. Before being shut down, the Slim lander activated its multi-band spectroscopic camera, or shortly MBC, in test mode, producing a few photos. JAXA believes that during the lunar day, the sun will reach a position to illuminate the photovoltaic panels. Then, the Slim lander might be revived. The American company Sierra Space is developing inflatable modules that could form the basis for future commercial space stations in low Earth orbit. In December of last year, a test took place at the Marshall Space Flight Center to answer a question often raised about inflatable modules. How well can this structure withstand pressure? The tested prototype provided an internal volume of roughly 300 cubic meters, about 1/3 of the total volume of the International Space Station. The maximum operational pressure in the module in orbit should be 1,048 hectopascals. However, for safety reasons, NASA requires the module to withstand 4 times higher pressure, that is 4,192 hectopascals.
Margin we have.
Go Sierra Space, go Aussie, go NASA. 55 psi, 55 psi. 63 psi.
To determine the limits of what the module can endure, it needed to be pressurized until it ruptured. The entire test was monitored by numerous cameras and sensors. The module finally experienced destruction at a pressure of 5,308 hectopascals. This means that the module exceeded NASA's strict requirement by 27%.
We're not a company that's trying to escape Earth. We're not a company...
Sierra Space plans to conduct further tests of inflatable modules this year, whether full-sized like this one or scaled-down tests of individual systems. This large transport container holds a very valuable payload. Inside is the return capsule of the Orion spacecraft from the Artemis 1 mission. As part of an unmanned test mission in late November and December 2022, it flew to the Moon and then returned to Earth. After landing, the Orion return capsule was moved to the Kennedy Space Center, where scientific experiments were unloaded and all onboard systems were thoroughly checked. However, the service of this capsule did not end there. Once the inspection and disassembly were completed, the capsule began to be reconfigured.
Bridge east.
The Orion return capsule from the Artemis 1 mission became an environmental test article. Orion received protective panels as well as crew-focused systems that were not on board during the unmanned mission. Once the transformation was complete, the test article could be moved to the Neil Armstrong Test Facility in Sandusky, Ohio. The footage you are watching comes from this facility. The test article will undergo tests that are part of the certification process for the crewed Artemis 2 mission. Specific tests include acoustic or environmental tests to assess its resistance to noise during launch or spaceflight conditions. Thank you for your attention to today's episode of Spaceflight News. We are delighted in your interest in space news, and to ensure you do not miss future episodes, kindly consider subscribing to our channel. Additionally, you can find other interesting news on our profile on social network X, formerly known as Twitter. The link can be found in the video description.